I'm excited to introduce to you all our guest speaker, Celina Mikolajczak. I hope I pronounced that right, but likely not. The Chief Battery Technology Officer at Lyten. So a little bit of a background about Celina. She's a distinguished leader in the battery field, renowned for her pioneering work in the battery sector, particularly for EVs. After earning her engineering degree from California Institute of Technology and her master's in mechanical engineering from Princeton, Celina's career trajectory took her from safety and failure analysis of lithium-ion batteries at Exponent to some of the key leadership roles at large companies like Tesla and Panasonic. And she now leads the battery technology efforts at Lyten, focusing on innovative lithium sulfur batteries. Aside from her industry achievements, as a fun fact, which I didn't know, Celina is also recognized for her early contributions to astronomy, including the discovery of several asteroids and a supernova at Caltech, which is very amazing. Her work exemplifies. Did you expect that one, Celina?
Yeah, that was a long time ago.
With a very interesting and amazing start. So please join me in welcoming an amazing person in our industry, Celina, as she shares her insights from her incredible career and her vision for the future of battery technology. So thank you for being here, Celina. How are you? What's your state of charge today?
Oh, I'm good. Every day is an exciting adventure, so just keep going.
Yeah, that's how it is. Can you take us as a start through your journey in the battery industry so people can learn a bit more about you, how you got started, and some of the key highlights of your life?
Sure. Yeah, so I always tell people I'm officially old. Um, when I was in college, batteries were not a thing. I mean, there weren't really even laptops, we were still with the desktop computers, and laptops, I think, were starting to come in when I was sometime in grad school, and they were very expensive. And, so, when I was in school, mechanical engineer, I was thinking, okay, you know, uh, my dad had done jet engines, and, I was kind of mechanical engineering, maybe that sort of direction, maybe astronomy. That's one of the reasons I did a summer internship where I was working with a team on a telescope. Um, but then I was like, no, engineering. Um, and I just didn't have an idea of what industry I'd be in. I had some vague ideas, and and then I did my first job. I worked in the oil field, worked for Schlumberger, saw what an industry looked like, was out on rigs and stuff. Decided it was cool, but not my lifestyle. Went to grad school. And in grad school, okay, you got to pick an area. And I was like, well, I'm a mechanical engineer. I like fluid mechanics. Just seeing how the oil industry works, it seems like we spend a lot of energy producing petroleum. Maybe I would find it relevant to look at combustion, because that has a lot to do with how we use that stuff that we spend so much time on. And, in that time, which was the 90s, like, people were just starting to talk about climate change, right? And most of us were
Mhm.
kind of like, oh, that's so depressing. We don't even want to think about that, right? So there's some guys talking about climate change, and the rest of us, we're working combustion, how to make more awesome jet engines and internal combustion engines and other stuff, right? Um, but that was kind of, that's kind of what was starting to happen. And, in that time, right, more people start getting laptops, cell phones become a thing, sort of. They're still crazy expensive, not for a grad student, but whatever. And again, looking for that job, and, what am I going to work on? Well, there were some friends of mine who'd gone to like GE, to the engine labs, or Pratt Whitney, where they were doing like fuel cell stuff. And I was like, yeah, that's okay. And then I got connected with some guys from Exponent who were doing this failure analysis stuff and working on these really interesting problems that were messy and exciting and seemed really relevant. And so I took the job, right? And I was like, this is the best job, right? And, you know, I was doing fire investigations, right? Some thermal science stuff. Got my first gig in batteries to take a look at the question of whether cell phones could start catch fire at a gasoline stations, like if they could somehow cause a spark in the fumes around a filling station, you know. And we laugh about that now, but back in that time frame, you know, this was like a concern, and people were like, "Oh my God," right? Um, so I worked with a colleague, a couple colleagues, and we did this report. And that was the first time I'd ever even thought about batteries, right? Otherwise, they were
Hmm.
just this other thing. And, you know, and that still remains in some ways true that batteries don't really fall into an academic discipline where they're deeply studied, right? So, you know, in mechanical
Hmm.
engineering, you'll go one of a couple of ways, right? But, you know, you might do fluid mechanics, combustion kind of falls in with that. You might do, you know, machine design or structural stuff, right? Um, double E, you know, you're looking at circuits, a battery is just a symbol on there, you put it on the board, right? You know, when you look at, you don't usually see anyone studying batteries in the undergraduate level, or you didn't, and for a long time you didn't. You might see people studying batteries in graduate school, and it's usually coming out of an electrochemistry department, and it's very electrochemistry focused. And I saw that in my
Yeah.
career for a long time because, you know, I was doing failure analysis at Exponent and, you know, learning about batteries at the same time. And, you know, we want to grow the group, right? So where do you find young engineers who know something about batteries? And you might find someone who had interned somewhere and done something about batteries, and maybe there would be a couple of electrochemists. Uh, and then, you know, you bring those guys in and they didn't know anything about practical batteries, like how they were made and why they would
Yeah.
fail or anything else, right? So you kind of had to teach that, right? And you know, and learn together as a group, right? So we did that for a long time. I spent I think 11 years at Exponent, and maybe about a decade of that I was doing batteries, and a lot of it was, you know, every now and then I get the Ziploc bag with a little, you know, burned up battery pack in it from a cell phone, or I get a bigger Ziploc bag with a laptop in it. And, you know, people ask the question, well, why'd it break? Right. Um,
Yeah.
but you know, you learn a lot doing that. You learn a lot from the failure analysis. Because you know, you got to consider the whole system, right? Was it designed improperly? Was it abused? How was it abused? If it wasn't abused, was it some kind of a defect? How likely is that to happen in manufacturing? It sort of uh, it drives you to look at the entire world of the battery, right?
Hmm.
Um, and that's the thing you discover is batteries are the super multidisciplinary thing, right? There's the electrochemistry that's happening,
Hmm.
but there's also the mechanical design of it and the industrial execution of it. And then on top of that, you've got, you know, how do you cycle this thing, which tends to usually fall into BMS development and the electrical engineering side. Um, and then, you know, how have you used it and what's been the customer expectation on this thing? So you look at this from a very multidisciplinary perspective, and that's what makes batteries super interesting, right? But the other thing that like failure analysis does is it teaches you to have some imagination. A lot of times, you know, you build a thing, does it meet the spec? Does it work? That's where, you know, as an engineer, you go, you're like, I made it work. It's this thing. See, I built it, right? It's great. And it takes like, you know, a lot of fortitude to then say, well, all right, so it works. What's going to happen to it in the field? How's it going to break? How are people going to break it? What's going to
Hmm.
happen if people break it? Right? That's where like safety stuff kind of rolls in. It's like, well, you know, I'm handing this thing off into the field. What are the implications of that? Right? And that's an abyss that you kind of need to look into as an engineer, and it's difficult to do because it's not all rosy, right? You're like, oh my God, you know, if
Yeah.
I do this wrong, you know, you have serious consequences, right? And you know, there's an abyss there with safety. There's also an abyss there when you start talking about like, you know, where are you sourcing your materials from? How is this built? What's the environmental implications? These are all abysses that, you know, usually when you're starting out as an engineer, you're like, I don't want to look over there. That looks really ugly and nasty. I'm not going to look. But, you know, starting out in failure analysis, you kind of get used to looking, right? And
And
then start
and
thinking.
what role? Mhm. And I was wondering, what role did failure analysis have when you entered into more large manufacturing environments such as Panasonic and Tesla?
Yeah. So, there's a lot involved in producing mass production anything, whether it's batteries or vehicles.
Hmm.
And you need to understand the processes, but a lot of times the success or failure of your product has to do with how well it's been designed, how it's been put together. And that all comes down to failure analysis because you design something, you put it out there and you try it and you test it. Ideally, you test it and you find out how it breaks, and then you say, okay, well, so it won't break like this again. Here's what I have to do, right? So it's always about reviewing the failures because that's where the deep learnings come from, right? And saying, okay, I've got to make it better, I got to make it better. In in any large scale manufacturing, people talk about the product, and the product should be great. Yes, the product has to be great, but then your execution of that product also has to be great. Really, a lot of times the difference between a profitable and unprofitable company has to do with their yields during manufacturing, has to do with the quality of the product coming out, right? So you have to spend time on that because, yeah, you can start with a great product, but if you don't manufacture it well, you're going to get eaten up by scrap and you won't survive, right? So, this is where you have to always be looking at that. How do I get better? How do I get better? How do I get better?
Hmm. Definitely.
Mhm.
And can you tell us a little bit about your transition going from an exponent to more leadership roles at the larger companies?
Yeah. So consulting was super interesting. There were a lot of different problems, and they kind of, it was always exciting, right? Like there,
Yeah.
wait a week, you'll have a new project and it'll be a new problem and be super stimulating, which is super fun. It's a great way to learn a lot. But eventually you kind of start craving something that has more large scale impact, right? And you're like,
Hmm.
wow, I can do this work, but what I really want to do is put a team together and we can tackle this bigger problem, right?
Hmm.
And that's when you kind of know that you're ready for management. And consulting company, you have some management, but it's really more geared toward the individual contributor, right? Um,
Hmm.
and that's really the focus. Whereas a manufacturing company, it's all about the team, right? Because you don't manufacture a car or a battery or anything as a single individual contributor. The whole point is, pulling a team together with lots of good individual contributors in it, and then tackling some of these bigger problems and addressing them. And when you feel like that, when you're like, I really crave that bigger problem, then you're ready to jump into management and leadership, right? And so Tesla was kind of that step for me. Like the technical side had kind of gotten boring. I really had seen a lot of the failures that I was seeing over and over again. And I was like, oh, it's that again. Okay. And then Tesla gave the opportunity to jump into like something much bigger scale and address a
Hmm.
whole new range of problems, and to do it then with a bigger team and with this growth focus, which, again, it was
Hmm.
the right time and it was amazing.
And I know you talk a lot about previously, even though being in the management position, you're always walking the floor, you're on the manufacturing floor. Maybe you can talk a little bit about the importance of being there in person and how that has played into your success at these management roles.
Yeah. So it's very tempting and easy to sit in front of your computer, right? Or in your office or at your
Hmm.
desk. It's very easy. You're already there. You've got like hundreds of emails coming in, right? You're like, I gotta get this done, and I need these reports and people need this stuff. It is like so easy to get wrapped up in that. Okay. Um, the thing is, it it's easy to get wrapped up in that and then to have the wrong impression about something. Okay. What you find out is that people who like are working on the floor, they'll send you a description of something or they'll take a picture, whatever. And and you'll think that you understand what the problem is until you go down there, right? And you get on the floor with your guys and you ask them to show it to you, or you just the environment actually is. And there's so much in environment, there's so much happening, that it's hard to get it through a computer screen, right? You just have to be in it. and you have to see what's happening. And then you have the right mindset to understand what people are telling you about. And it's super invaluable.
Mhm.
And, it's one of those things where, you know, if you have to walk the floor, you have to see what people are doing. And it has to be routine, and it's harder and harder. The more you get up in management, the more people try to divorce you from that, and more you are divorced from that, just
Mhm.
generally. So you have to make it a plan to do it. The other thing is, what I found was that um, people kind of don't expect management to go walk the floor, right? And when you do, it's like a pleasant surprise to everyone. They're like, "Oh wow, they actually came out to see what we're doing, right? We must matter. Yes, you matter, right?" So, it like, first of all, people want their management to know what they're doing. And so when you show up on the floor, you're respecting them, right? And appreciating them. And that's
Mhm.
really important. But the other thing that happens is people are like, wow, she's not afraid to come out and, get on the floor, to put on steel-toed boots and a hard hat, or to, you know, get dressed in all the gowning stuff that we have to do to get out on the floor. Like, she'll actually come out here and take a look. Damn. Okay. Right? And that's like hugely important for people to respect you as a leader, because they know that you're not afraid to go out and see them and see what's happening.
Mhm.
And they also feel like, okay, well, this person understands what I'm dealing with. And so maybe, maybe I trust them to be my leadership, right? Like, nothing worse than like, oh, the boss doesn't know what I'm doing. The boss has no idea what we deal with. Like, I'm betting people have said that, they've heard that all the time, right? That sucks, right? So as the boss, you've got to
It's really
make
helped
sure.
to gain trust, right, within the
Yeah,
team. Yeah.
yeah,
Mhm.
exactly. And you see stuff too. You get on the floor and you're like, mm, that's a problem. Okay. And I also encourage, people in upper management too, right? If there's some social things that are not so good happening on the floor, you're more likely to know about it if you go out on the floor, right? And,
Exactly.
people like, oh, okay, the boss comes out here and walks out on the floor. I'm not going to be, not going to do all kinds of, bad behavior necessarily, right? Um, and then, oh, well, you know what? 5S, it does matter, right? We'll keep the floor clean because the boss comes out and sees, right? And if it's filthy, we're going to hear about it, right? Or, it's one of those things where you're like, wow, that is a really unsafe process, or you see something, you're like, that is not cool, right? And then people are like, wow, okay, boss values that. Boss values our health and safety. We're going to pay attention to that stuff because the boss does, right? So it drives all kinds of
Mhm.
goodness into the organization.
Yeah, definitely. I think that's a great lesson for all of us here who are thinking of transitioning from technical roles to more management roles, to never be too far removed from the technical aspect and to use all of those skills you learned and implement them even when
Mhm.
you are in management.
Yeah.
Great. And now I'd like to talk a little bit more about your experience as a woman in the industry. So I can only imagine you walking the manufacturing floor of Panasonic, surrounded by all of the men. So how was that experience?
Um, I love hanging with the dudes. Okay, honestly, I love hanging with guys. It's interesting. I'm shorter than everyone, so I'm constantly looking up, right? Um, which is funny because, like, to me, all the guys are taller than me, largely, right? And so I'm like, when there's a really tall guy, I'm not like differentially intimidated. I'm looking up all the time anyway, so whatever, right?
Everyone's tall. Yeah.
Everyone's tall, yeah, exactly. So there's a lot of that. You know, uh, it's different. Um, you know what interacting with a largely, male workforce. Um, you do need to understand what's important to the guys. And what's in the noise, right? I think one of the key things that people want to know from all their managers, right? And it doesn't matter if it's male or female, but everyone wants to know that their manager has their back and that their manager is going to fight for them, right? And I think one of the things that women run into is people kind of look and they see a girl, they see a woman and they're like, is she going to fight for me? Or is she going to bend?
Mm.
Is she going to just like let other people walk all over her? And then, because they're worried, they're like, if I have a manager or a boss that lets people walk all over them, that's going to negatively impact me, right? And they're like, then I could get, I'm not going to have that protection of my manager from above that's not going to be able to get our voices heard or, get us the resources we need or explain what we're doing to their management, right? So people get concerned about that. And that's where I think a lot of women, can run into a problem that, a lot of times as women, we're socialized to be nice, to be accommodating.
Mm-hmm.
And, uh, you know, and as great as that is from a social setting, from a business setting, your team doesn't want you to be nice and accommodating, not all the time. They want you to be nice and accommodating to make sure they get well taken care of. But they want to know you're going to go out there and you're going to say, to your boss, hey, my team's really struggling. I need more resources here. Or, we really need to change this and that you get that done. Right. So I think it's really important that women realize that they need to cultivate that confidence for their team. The team has to have confidence in them that they're going to go for it.
Mm-hmm. Definitely. Yeah, that's an interesting perspective. And as a leader, how have you been able to show your team that you will be there for them from that perspective, or to show that, standing up
Yeah.
for the team and yourself as well? Yeah.
Yeah. So you can't run away from every conflict. You can't run away from conflicts. You have to see, people have to see that you're going to stand up for them, that you're going to, if there's a conflict that's brewing, you can try and diffuse it, but you can't be a pushover, right? And people have to know that. They have to see that. They also have to see that you're going to dive in there with them, right? And, one of the early days in Tesla, um, we were having, some quality issues with our cells on the line. And what it involved with was actually opening boxes and inspecting the cells, right? And there was a whole thing. Like you had to open the box, you had to flip the cells over, which was a trick, and then, flip them back. It was hilarious. Okay. Looking back on it, really funny. At the time, like, oh shit, right? And we were using a lot of cells. There were a lot of boxes, right? And you know, it it was like I was leading quality there, and my team and the production team, we were all doing inspections, right? It mattered that I went down there and and spent like a Saturday morning, afternoon flipping boxes next to production, right? And that, I took my turn with my team members to do literally the heavy lifting, right? And for years I would ask like my
Mm-hmm.
intern applicants, like the intern would apply and I'm like, okay, so how do you feel about lifting heavy things? Right? Interns thinking I'm going into I'm an engineer, I'm like not gonna do that. But the reality is sometimes you got to get in there, get your hands dirty and go lift heavy things, right? And and that gains you, again, it gains you respect. The team goes, yeah, she's not afraid to get in there and work just as hard as the guys, right? We don't have to be like, she's not fragile, she's not delicate flower, she's not gonna like send the guys off to do the dirty work and like, clean hands and everything. People hate that. Okay. Like I remember some of the Schlumberger technicians that I work with, they were like, they had zero patience for what they called the hands in pockets engineer. Like the engineer that wasn't ready to get in there and like get dirty, no patience. Right. So when you show that, it matters.
Great. Yeah, definitely some great takeaways. Get down there, get your hands dirty, have confidence. I think that's really helpful for both the young professionals on the call and also those in management. And a little bit more on kind of giving advice to the audience. With your extensive experience in batteries right now, where do you see the most significant opportunities for women in batteries?
Mm. So I think batteries is a great subject for women because it is so multidisciplinary, right?
Mhm.
Um, it's it requires you to think across all the different classes you had in university, right? So you need to pull stuff from all of them. You can't just say, "Oh, this is my battery know-how," right? You've got
Mhm.
all the engineering, right? And bringing that together and integrating that and having that breadth of thought, I think is something that I think a lot of women do all the time, and they don't realize they have that integration skill, right? And
Mhm.
and it's like, yeah, you have that integration skill, use it. And batteries is like a great way to do that, where you can pull all that stuff together. And I laugh and, I consider batteries and I'm like, well, all of my like metaphors for how batteries work, and people ask me like, how's this made and this, that, and the other thing, they tend to go back to cooking, right? I'll tell people like coding, you make a slurry. What's a slurry? It's your pancake batter, right? Take your pancake batter, mix it up, right? That's a slurry. Spread it over some tin foil in your kitchen. That's what coding looks like, right? So, it all comes back to my kitchen, right? But, it's one of those things where doing batteries is kind of like cooking. You're pulling all kinds of information in from all sorts of different sources to cook. And it's not like this is how you cook. No, it's like there's a lot of creativity there. There's a lot of stuff that you have to pull in, a lot of thinking, and you do it, right? So, I always feel like, look, if you can cook, you can do batteries, right? And
Mhm.
it just takes some like, okay, I'm going to have to just think broadly and I'm going to have to learn, because that's the other thing. It's still not taught really as a class in any university, right? So you're going to have to learn, and you have to learn from everyone, and you have to keep your ego under control, because you're going to learn something from everyone, and you're going to learn a lot of great things from your lowest paid operators. And, as long as you can keep your ego under control, you'll do great.
Yeah, that's definitely great advice. Right. Well, I have so many more questions, but we're nearing the end of the event. So I'd like to finish off with a lightning question round where the audience can quickly get to know you better, and then we'll move on to Q&A. All right. So are you ready?
As I'll ever be. Okay, go for it.
All right, real quick. What's your favorite battery chemistry?
Well, I'm spending like 12-hour days working on lithium sulfur, so it's that. I mean, I love all batteries. I love lithium-ion batteries, conventional ones. I got two Teslas and some Powerwalls, all different versions of, NMC, NCA. Super fun. It's nice. But lithium sulfur, oh, it's a whole other world, and it's really exciting.
That's great. Yeah, we have quite a few lithium sulfur specialists on this call, so maybe they'll ask you some questions during the Q&A. Okay, if you could design a new type of battery cell, what would it be like?
That's kind of what I'm doing actually at Lyten, right? We're designing lithium sulfur. It's all
Yeah.
new. It's like the sheets, it's a blank sheet of paper, and we're going for it. So, and we're doing it because it's got great potential in energy density and
Hmm.
cost and availability and throughput. So yeah, I'm kind of doing the dream.
Yeah, you're living
Yeah.
it. Do you have any book recommendations for us?
Okay, I'm gonna admit, I read books to relax, okay, and not like.
Yeah, we like a relaxing book. It doesn't have to be
Okay.
batteries.
Yeah, I mean, I read a lot of technical stuff. I'm a huge science fiction fan, okay? Always have been, you know, I like science fiction with lots of strong female characters in it. I like stuff that blows your mind. Uh, I grew up on like, Ursula Le Guin's books and like Anne McCaffrey's books and um Madeline Langle's books, right? The Wrinkle in Time, right? That was like the 80s, well, 70s and 80s, right? Um, these days I'll usually read anything that Neil Stevenson writes, right? So like, Snow Crash was the start, and a bunch of his other stuff is super fun. I'll occasionally read some fantasy.
Great.
I loved The Expanse, right? It was on, I forget, it was a show, but the books are great too. Uh, yeah, like I said, if it's got a strong female character, and it's sci-fi, I'm usually up to my eyes in it.
Great. We'll add that to our reading list. Some great titles. Okay, final lightning round question. If you were a battery cell, what special performance attribute would you have?
I think energy density.
Energy density.
Yeah.
Any specific reason?
Um, just because to do this, to do a startup, to do a new chemistry, to try ramp something, um, you just need to have stamina and you just have to go and go and go and go. It's like, people say, oh, it's not a sprint, it's a marathon. I'm like, no, it's not even a marathon. This is running the Iditarod, guys. This is like getting out there, going across the frozen tundra with dogs and like all kinds of stuff that can happen. That's gonna happen at you in an uncontrolled way. And what you need stamina and just intensity and focus, and so energy.
Yeah, I can only imagine that. Thank you, Celina. Now we'll move on to Q&A.